Hello everyone, I'm Thomas and this is day 38 of 100 Days of Code in IoT challenge. Now that we have logging done and we have our futures implementation ready, I can start moving all the code into a single place that is a rapid prototyping library that I called Uniuno. And today's plan is to move all the code into a single place and start adapting the core callback-based library code into a new approach that is gonna be future-based. Let's move to the code. Okay, cool. So I'm going to start from opening Uniuno project. The reason I'm opening this one is because this is the name of the library that I'm building here, the library for rapid prototyping of IoT that supports rapid prototyping of IoT devices. So all of the utility classes for IoT are going to be kept here. As you can see, I have already copied everything from the core library, another library I have created in the past. And also, for those who watched the video about unit testing, I have something tested here, which is the event dispatcher, and that is tested with the Google test. So we've got something already here. But yeah, basically that's not everything. There is much more work to be done. Okay, but for that work that needs to be done, let me quickly show you what is the goal of today's coding session or refactoring session, right? So yeah, the main objective is a switch to futures. So yeah, what do I mean by that? So the day before 3 days before yesterday, right? For those days, I have been building the futures implementation. Let me show you an example. So I'm going to open WiFi Manager.hpp and the connect method here, right? We've got the callback approach. So it is required, the method connect requires developer to pass on connected function, right? Lambda function to this method, and this function is going to be executed once we are connected or the timeout has passed, right? So that's the approach we've got with the core library. And as long as it is working well for for some use cases, there are use cases like, for example, with HTTPS client, where this doesn't really make the code clear. So have a look here. So for the send request, because send request is also non-blocking method that takes a callback, I had to introduce this sort of nesting here, right? So we've got Wi-Fi Manager connect, then the callback, the big callback is passed, right? And then inside this callback, we have another function call that takes another callback, right? The set clock. This is not very convenient way of implementing this. And also for the developer who reads this code, is not very clear, right? And this can be mitigated easily with the futures. So as I said, I started 4 days ago and I built, let me show you, I've got it somewhere here. I've got this project. So again, showing for those who haven't watched the video. I've got, maybe on the embedded it's gonna be better. I've got that library that allows you to chain the non-blocking functions like that, right? So you have and then, and you can have either futures chained together, right? Or just a callback that is called once the future resolves, once it resolves, right? And what is resolved? So resolved is when this, like for example, this future here that is based on time, right? It takes the poll function. These features are poll based. So it takes a poll function, poll callback that is going to be called constantly. And as long as it returns pending, right, then it is going to be like, called until we have either resolve or reject in a case of error, but I don't have it covered here. It's in the native tests, right? So this sort of chaining, that's gonna improve the code cleanliness, and it's gonna make the life easier on ESP8266, in my opinion, right? Let me know what do you think in the comments. Okay, so this is actually going to be the main goal, right? To adapt the existing code with the callback approach to the futures approach. So for the Wi-Fi Manager or for the HTTPS client send request, we're going to send, instead of void and taking the callback, we're going to return a future, right? That you can chain easily. And also inside the body of those functions, wherever there was a need to do something non-blocking, I'm gonna do the futures now, the futures approach. Okay. So yeah, so that is the main objective, switch to futures. But additionally, I have three more, and there is one thing that is really a part of the futures, but I'm gonna talk about it once I explain you what I've changed in these futures, because they slightly different than when we've been implementing them together, right? Not very, it's just some improvements I added, but I'm gonna do a walkthrough, so no worries. Right, so additionally, move all the code to the common Uniuno library, right? I've got it already opened, and I'm just gonna do it in a second because I've got the future projects opened as well. However, this also applies to logging that I have done yesterday. So I guess, it would be nice to have everything in one place now. Then I have add unit tests where possible. So I'm gonna try to implement some unit tests for the classes like, HTTPS client, set clock, timer, Wi-Fi Manager, but we'll see how it goes. I don't want this video to be too long. And switch to auto typings, and this is really about event dispatcher, where like on and once methods, you need to pass a generic argument for the event type. There is no way to not pass it, right? So it is required because we use a lambda function here, C++ lambda function, and this can be changed. This can be improved in the way that you won't need to pass. You won't need to use this sort of brackets for the template and pass the event type, right? The event type. But the compiler is gonna just take it implicitly, like understand based on the given argument what is the argument type of that lambda function. But I'm gonna show you how I've done it with the futures, because this is one of the improvements I've done, so you will understand. Nice. Okay. Yeah, and this is really it from here. This is just one slide with all of these objectives. I'm gonna keep my Google Chrome open because today the session is gonna be slightly different. Like in the past, when I ran into issues, I usually did a cut. I've been investigating, and then once I had the problem solved, I just described what was the problem and how I solved it. But today I'm gonna try a different approach. I'm not sure if it's better or not. I guess you will tell me in the comments. But I would like to try to do full implementation, just to show you exactly what is my thinking process and how this all how this all coding looks like really, right? So what problems I really face and how many times my code fails to compile. So yeah, it might be interesting, might be not, but let's see how it goes. Okay, so going back to IDE, and the first step is going to be copy, paste all of those files And by all of those files, I mean from the futures project, entire src is going to src of Uniuno, and future test from the test desktop is going to test desktop in the Uniuno, and test embedded, also future test going to test embedded. So we have all the tests now in here. Right, okay. And before I explain what I've changed in the futures implementation, I'm gonna try to run all the tests. So I'm just gonna run PIO tests. And here I've got my ESP8266 connected to my computer. So the test can run in the embedded environment on ESP8266 as well. So let's see what we get. We should get, all the passes, right? Because moving the files, the fact that I moved the files, shouldn't affect anything, but it seems like it's fine. So let's see how it goes with the embedded environment. Okay, so yeah, all passed. That's very good news. So I don't have to fix any issues at the beginning, right? So now let me show you the futures, the futures improvements. So first of all, what I've done is I have added some more tests, right? You probably remember these tests to check different template specializations. So I think, yeah, this is all covered. And if you haven't watched the futures videos and you would like to find out about the details, have a look at the description of this video, and you can find the links to these videos. Because yeah, I'm not really gonna talk about this much. That just verifies all the types of futures, because essentially there was a requirement to have a few different template specializations for the future, right? You see, it takes two generic types, and we have cases where one of the type is void or both of the type are void. And the code for these cases needs to be slightly different. So that's why I had to do the template specializations, and that's why we have more assertions and more futures created for all of those tests, like for checking the state pending, for checking the state resolved, and so on. Okay. And what I've really changed is one thing it's not really changed what I've added, right? So one thing is this test void and non-void chaining for futures, right? So that just checks the case where we have the future that is void and void. Its input is void and output is void. And we have another future that the input is void, right? It has to be the same as the output of the previous one, but the output is int. And then another future that the input is int, right? Has to be because the output of the previous one is int, but the output is void, right? So it's like, testing all the combinations between a non-void and void. And this is for the future objects, right? With the polling callback. And this is the test for just callbacks, right? So these are once single call callbacks, right? So this code here in those callbacks is executed once the previous future is resolved. So basically, once we have F1 resolved, in this case, all of those are gonna be fired sequentially. Okay, and this also works like with void int. Then we have int to void, then from void to int. And again, from int to void, and I think we have at the last one. The last one is void, right? You may have realized, for those who watched the futures videos, that there is no generic parameters here anymore, right? I just passed the callbacks, and I'm gonna explain the reason in a second. But yeah, let me show you some more extra tests. So I've got the error handling tested with the default error here. So this is the case where we have the rejection. And also with the mocks, I make sure that if the first future rejects, the next future pending callback and the next, callback, the immediate single call callback are not fired, are not called, right? So I'm checking that with the Google mock expect call, right? So that's one test. Another test is to check the custom error. So that was something we've done during the last day with my error, but here I've got custom error because I think it sounds better, right? And for that, I have two cases. So one case, this one is in the first future. So that means the first future rejects with the custom error. And here again, I checked, the next futures in chain or callbacks in chain if they are not called because they shouldn't be. But also, that checks the integrity of all the types. And the same thing happens here, but this is for the last future. So here we have a chain that is fine. There's the first future, right? And the last future is rejecting. So we're checking if we get this last error. Okay. So that's how it looks like from the test perspective. And from the code perspective, one main change, except for those specializations that I've already showed you, but now they are different because there is an error handling, and that error handling is a part of them now. So you see, we have type name error for this is the main one. This is the one we've worked with, right? But there is the next one that is with the input, but no output, just an error here. And the behavior is very similar. This code is probably not perfect. There is a room to there's some duplication that can be removed, and I might do it in the future when I be working with that code. This is not the last stage of it. However, I'm gonna keep the interface, right? All the methods, all the signatures and everything is gonna stay the same, for the backwards compatibility reasons. So there was one specialization with no input, with no output. This one is with no input. I mean, no input, but by no input, I mean just the void input, right? And no output was the void output, right? So another one. And I think in this one, there is some complication. Yes. So this is where the complication begins. Okay. So in order to get rid of this requirement for providing the generic types like that, right? However, not for this case. Sorry. This is for the case where you pass just a callback, right? So this is the single call callback. So there was a requirement to pass something like that before, like explicitly saying that function passed to the end then is actually, returning void. So it doesn't return anything. Or if it returns something, it returns that particular type. And I figured out how to do it, with the, meta programming and with this approach, this thing called, I keep forgetting about this, that is called substitution failure is not an error. So something popular with meta programming in C++. And I figured out the way to, instead of taking the lambda function that really for some reason, it removes the types, right? It removes the types on the way. I think that this is probably due to lambda function being a class with the function call operator overload and something internally there. I'm not really sure how exactly this works in details. I would have to check. But the problem is that those types, if you have these types defined like in the event dispatcher here, right? Where the event type is here is the argument, right? But it could be also on the return type. So these are lost, right? These are lost for some reason because of this, the lambda function. And the compiler cannot really identify them implicitly. And because of that, the developer is forced to pass this as a generic parameter. And I've just figured out, it took me lots of time. I figured out how to do it with this substitution. Again, a failure is not an error, right? So here we need a private method. This is another interesting thing about C++ and these substitutions, the template substitutions. So apparently, this function traits, this is from the Boost library. I had to download it because it checks the function call operator, this one, right? When I had it here as a part of this template, then I had an issue because this future type doesn't have this operator. And apparently this template system in C++ works in a way that, is not really like you would expect in a simple Boolean condition, right? Think about the simple Boolean condition where you're checking if two values are true with AND operator, right? So we have value 1 and value 2. And the way this works is when the first one fails, when the first one is false, it doesn't even check the second one, right? It just returns false immediately. But here with the template system, it's not really following that approach. It's a bit different. So it really checks all of them. It still checks all of them. So if you have any traits here as the substitution, again, substitution failure is not an error. You've got it here, right? To identify if that, template is matching your code. Then, it's still gonna check against like anything that you pass to and then. And there was an issue with that. But I found a workaround, which is creating another method. And because that method is never gonna take a future, it is just working, right? So I thought I had just, some sort of like, a method just called straight away, right? So this is sort of like proxy. And here, you see, this is where the real complication happens. So we have this into future. We have two, right, of them. So this is another overload. And the way this works is, as you can see here, I don't have std function anywhere anymore. I just have this class F template and this ampersand, double ampersand fn. And I deduce the type using like this different way of defining method, right? So it's auto type, but we define what it returns here. And I use this decal type and I deduce it from the function and from the fact that I know what is the input type, right? In this case, I know what is the input type. The input type is O, right? Because for and then the input is the output from the actual future. So with the decal val, I was able to determine that. And when you do this, it just returns the return type of that function, right? And because we're really returning just another future here. So what happens is one of those methods are gonna be used depending on the case. So let's have a look what the case is. So that uses C++ enable if. Enable if works in a way that if the condition here in the enable if is true, right, then it's gonna use that method, right? If it's false, it's not gonna use. So if both false, not gonna use both of them. If one of them is true, it's gonna use. If both of them is true, it's an issue, it's an error, it's gonna complain. Okay? And what I check. So what I check is for this f, because this is really the subject. This is the type of the function that is passed to and then. And this is just about the function. That's why it's also called f. I'll probably rename it later on to function type or something like that. And what we check in here is if the argument, the first argument given to that function is type of O, right? This is right, logical, right? Because, output again from this particular future for the next future is going to be input. So we care if this is O. I check also if the result type of that function is void. This is needed for the implementation. And yeah, this is actually it, right? This is actually it. So the result type, and if it is not void, in this case, it is not void. It is not void, then we know that we should actually resolve it with something that is, that returns, we should actually resolve it. I think I spotted an issue here. So yeah, so that probably should go inside. Yes, there should go inside. So I spotted an issue. You see, my code is not perfect. Probably didn't cover this case. So this, if there is a return type, right? The return type of the function is not void, then we want to resolve with this value. Then we want to resolve this with value, and we basically know that this type is essentially, this could be also function trace really, but we know that this type is not void, and we can do this, right? And the other case that still checks if the input type is, which is, the O, is O, right? If it's not, then it's gonna fail. And here we check if the result type is void, because if it's void, we still want to call that function, right? The given function here, but we want to resolve with the void, okay? And this really covers these cases. Let me show you. These cases, right? So that's the case where we take int, but that returns void. So we still want to call that function, but because it returns void, we cannot pass anything to the async result, okay? And this one, we actually return something, but we take void, okay? So this is the difference, right? Yeah, sorry, this is a bit confusing. I think I can improve this code, add some more readability. There are some tricks, ways to make this substitution failure is not an error kind of code with the meta programming clearer, right? And yeah, for all the rest, there is no case like that anymore, because for void, we don't need to worry about this, because then we know the input and output is void, so we don't need to check if they are, because they are defined like this, and this is required. Okay, so yeah, so this is how the future works right now. The use of function traits again. So this just helped me to determine those types based on F, right? Yeah, that's like, the level of complexity here is even higher. To understand that, I would have to spend like lots of time. I roughly know what's going on, so that's enough. Okay, cool. I did a small change to my code over there. Let me check. Maybe just on the native environment, because there is more tests on the native, if that code passes. Cool. Yeah, so we've got everything nice. Okay, so I explained the futures, and was there any difference to async result? I don't think so. No, so it was just no, there was no difference. Okay, so I explained that, and now I think we could start the coding finally. One more last thing to mention. As you probably remember, those who watched, those who haven't, let me tell you. So chaining the future itself, regardless whether you do it with the callbacks or you do it with futures, this doesn't do anything on its own, right? It doesn't mean this is going to execute. You need a piece of code that is going to make it happen, right? Piece of code like that one. This one uses while loop, and it iterates, like, it keeps calling the general merged future, right? Until it's not pending anymore, right? And for that, really, we cannot really use while on embedded environment, right? We should use the loop method. And ideally we would have some sort of an object or a function, probably object, that works in a form of a queue where you can just add futures, right? So you just add the futures and that makes sure they are executed on the loop. So that's going to be something I am going to implement. It is called executor. It is not one-to-one to how the executor works. I'm not sure if executor is really a pattern, but this whole thing is really the poll-based futures. For me, this is really I did it based on the inspiration from the Rust language. Even though I don't really know Rust very well, it was just, the main concept, right, of the polling future and having like executor that you can, just add some futures over there because, it's more, it's not like I've done it here. It's different. They have threads and other stuff that I have to also figure out with C++, but not on ESP8266. It's going to be ESP32. On ESP8266, the threading is not really possible or stable, something like that. So yeah, but still we need some sort of I'm going to call it executor, and this is really going to be just the queue where you can add some futures, and that's going to make sure those futures are executed on the loop. And ideally that would be without even use of the loop, which is possible with the schedule function that is built in here in the Arduino framework for ESP8266, and I'm going to show you. So there's going to be also, I'm going to have to quickly implement it at some point, right? Okay, cool. So let's pick the first class we're going to adapt to the futures. You know what? I think we can start from the Wi-Fi Manager because that seems to be the simplest one. If we have a look at the connect, here is just this bit that is really asynchronous, right? And that is with the use of the timer. So we could potentially get rid of the timer completely in favor of the future. However, we're gonna need to do this executor at some point as well to really verify this test. We could do it in the future, but I need to right after that introduce the executor. So that's what we're gonna do. Disconnect needs to be a little bit improved. And also there is this class really lacking functionality. Let me tell you. So at the moment, this is only works in a way where you try to connect. And, you don't get information, how long your connection is, retained, right? So it doesn't really handle the cases where you are connected to Wi-Fi. And let's say 5 minutes later, the connection drops. There is no information to anyone, right? And to any place in the code. Even though we use dispatcher here, that dispatcher is not utilized to handle this case, right? Probably because I didn't have to do it. But if you want to build a production grade code, that would be nice to have, right? So, I'm just talking about two approaches to the IoT devices, programs on the devices, okay? So one approach is when you, let's say, you want to do, maybe, this is like a cyclical, right? Like in cycles, or maybe it's, depending on the other conditions. But so there is some sort of event triggering it. And by it, I mean, some sort of event, some sort of action. And when it happens, right? So it's either, a cycle happens every X amount of time, or, there is something else, some sensor triggering it. And when it happens, we want to connect to Wi-Fi, do something, and disconnect from Wi-Fi. And that's it. Okay? So this is the case where this implementation of connect comes handy. Because that's what we want to do, right? We want to, this is still it's a asynchronous operation. At the moment it is, right? With the unconnected. But the way this works, this allows you to, execute that, wait for connection, right? Then do something maybe, because, we may want to send some request or something. And then after, just, do something, send some request, and after just disconnect, right? So this is one case. And another case would be slightly different. That would be the case when we want to stay connected, right? So we might want to we still might want to do it as a non-blocking operation like with the future. So we connect to Wi-Fi and we're waiting once the connection is established. So that would be the setup of this, right? Like a begin function or method. But once we connect it, we would like to make sure we connect it all the time. And when we disconnect it, we would like to send some notifications, notify some subscribers, some callbacks that are subscribed to that particular event, right? And it doesn't happen at the moment, right? Because I only dispatch the connected event when we have a transition of state from not connected to connected, and when the disconnect method is called. So these are the only two cases for that. So yeah. So unfortunately, this is not handled, and I would need to introduce something to this class. Maybe not today. I will see how it's gonna go with the time. But at the beginning, we're going to focus on maybe writing some tests, but mainly to turn this into a future instead of handling the callback. Okay. So let me create a test for that. First of all, let me think about what kind of environment we can test this class in, right? We have native or the embedded one. Some classes, unfortunately, we can only do in the embedded one, and this class might be the case because we use internal classes, internal objects like ESP8266 Wi-Fi multi. However, this one doesn't seem to be a big issue. Yeah, I will check in a second. And I use the Wi-Fi in that way, but there is nothing stopping us from just receiving a pointer to this Wi-Fi class in the constructor. Okay. So, let me have a look at the implementation. So we're going to have a look at this Wi-Fi thing first. So Wi-Fi is ESP8266 Wi-Fi class. And what we are interested in is the methods. Is the methods that we call. We call status and we call mode. So let's have a look at these two methods. They are not really here. So they're probably on the generic class. And what we've got the mode. Right, I see, okay. So we've got mode, and we probably have a status as well, but I already see it. There is no virtual methods. And unfortunately, without virtual methods, it's not super trivial thing to do to use the Google mock, because Google mocking non-virtual methods, right? Is there is something, hang on, because yeah, that's what I thought. So Google mock can mock non-virtual methods. Okay, so I'm a bit surprised because I thought it's not possible. In this case, instead of sharing common base class with the real class, your mock class will be unrelated to the real class, but contain methods with the same signatures. The syntax for mocking non-virtual methods is the same as mocking virtual methods. So how this is working? Simple packet stream class. None of its members is virtual. A mock packet stream class. It inherits from no other but defines get packet and number of packets. Right. So we just say, okay, so that gets get packet. And where does it come from? Mock cons method get packet. Oh, there we go. So this is get packet. Right. Note that the mock class doesn't define append packet unlike the real class. That's fine as long as the test doesn't need to call it. Next, you need to, okay. So that seems like it is possible, so we can give it a go. So we might not need to do any, we might not have to use the embedded, which is a bit more tricky, right? Because to really have, to really have like, deterministic tests, where you don't need any external conditions for the test to give you the exactly same results every time. Especially for the Wi-Fi, that would be difficult, right? With embedded environment, because on embedded environment we would have to check like real connection with Wi-Fi, and for that you need to have this internet and the credentials in the place where you run the tests. Okay. So that's, you could change it, right? You could change it in the code, but, so much complexity. Maybe we can avoid this. At some point, we still need to have like, more, maybe sort of integration test where we check like, different moving parts together. Or like we have one general case for the Wi-Fi manager. So we check, like the behavior with something else, or there is still like some room for this sorts of tests, especially for the particular device. Okay. But yeah, for this one, I'm going to give it a go and try to use this Google mock. So what we need, Wi-Fi Manager, and for the test desktop, I'm just going to create the test. And what we're gonna need is gtest, and we need gmock and gmock. Okay, so these two, and then I'm gonna define the test itself. So that will be Wi-Fi Manager, and what we really want to test first. Let's think about it. So I would like to test if that would be on the connect method, right? So what we want to do is to see if maybe this case, the first case, the simplest one, right? So if the Wi-Fi is already connected, so if Wi-Fi status returns WL connected, that means that should resolve, right? So test connect resolves with WL connected if Wi-Fi is already connected. Okay, so that'd be the first test. And how are we going to test that thing? Okay, right. Before I finish the test, I need to do some modifications here. So let's do it now. It's not really the practice you would do if you wanted to really like refactor legacy code. But because this is not really critical component here, and this is still early stage, I can allow myself to do this. So first thing is to get rid of timer. Timer not needed anymore. Bye timer. Private going to the bottom. Removing timer from here. Right, so we don't use timer anymore, and because we don't use timer anymore, this code cannot be run anymore either in this way. Okay, so this is sort of like we sort of breaking it. That's something I'm gonna comment out, and yeah, that's not gonna return anything. Okay, that needs to become a future. So maybe for now I also comment it out, because we're really testing the first case. And this first case runs the status on Wi-Fi. And because we use Wi-Fi straight away as a static class. That needs to be changed. So I need to do something like 8266 Wi-Fi class. Wi-Fi, not WOFO, Wi-Fi. I'm gonna do some changes in a second as well, because I think you also noticed, maybe someone already complained, I don't know, that I'm not consistent with the naming. The reason is I'm changing the names, right? I used for the class members, for the methods, variables, I used a camel case, and I'm switching to underscore. I'm switching to underscore because I see in the standard library of C++, this is the standard. That's the main reason. I know there is a huge debate in C++, and I already sort of like, switching from one to another, but from now on, I'm going to stick to it. So, underscores and, just following the standard library, for the formatting, right? So please don't be angry. So yeah, that's what we need. Wi-Fi pointer. That is also something that needs to be figured out, because it is a bit wasting, it's a bit waste of, might be considered as a waste of memory. Still, like, keeping the pointer here. But yeah, this is just prototyping, isn't it? Right, so we have Wi-Fi. Wi-Fi now is a pointer, so we can call it like that for the mode. And here we can call it like that for the status. Okay. Right. So now let's come back to the test and let's try to write a mock. Something like they did in here. So, mocking non-virtual. Is there anything? Hang on. Note that mock class doesn't define append. Okay, that's fine. Note virtual and two classes are unrelated. You must specify your choice at compile time as opposed to runtime. Oh no, hang on. Template class packet stream. So one way to do is to templatize your code that needs to use packet stream. More specifically, you will give your code a template type argument for the type of the packet stream. In production, you will instantiate your template with concrete packet stream as the type argument. In test, you will instantiate the same type with mock packet stream. For example, you may write. Oh, no way. I don't like it. Okay, no, really, no. Yeah, unfortunately, I don't really like when my tests force me to change the production code. So that was something I was talking about. That requires some extra work. Right, let me check if there is anything I could do and keep this. Yeah, I could do it with a facade. That's the only thing I could do. So maybe I do it. So there is this facade pattern that I can introduce here. Let me show you. So this is like my this is how the programming looks like with learning and everything, right? This is how it looks like in action. So let's have like Wi-Fi, maybe ESP 8266 Wi-Fi. I'm gonna call it facade.hpp. I'm not sure if this is the best approach, to be honest. But let's give it a try. I don't really want to run them in embedded environment, these tests. Okay, so what is facade? So facade is sort of like, it's like facade, right? It's like a wall. So you have, you define there a method that are really just, you know, sort of proxy to something else, right? So this just like it's like it separates you from some legacy code. Usually you use it with the legacy code. So let's say you have like lots of classes, different objects, different methods on one side, and another side you have a clean code, and you need to somehow communicate with the other part. But you don't really want to deal with all of these objects separately, right? Because these are ugly, and the way you need to construct them are not really clear and everything. So that will be the case. And so what you do, you just create one class that is sort of like a proxy to this, you know, blob of code, which is not nice, right? So this is what I'm gonna try. I'm not saying this code is not nice, what they've done, but I'm gonna have to try to implement this. So let me try to do this. So we have this facade, and this facade. The problem here is that needs to have a virtual functions. Virtual methods. Sorry, this would we need virtual methods. You know, that's still like, you know, sort of like forcing me to do some implementation here. But yeah, I'm gonna try at least. I prefer this one than the generic approach. So what methods do we need? What do we need? We need mode. So let's go for it. So we need mode. We don't need all of this, but yeah, this one. So this is one thing, one method that we need, mode. Then we need, I can put them together. That's a plus, definitely. So add access point. That's also Boolean. Okay. And we need, what else? Status. That returns WL status. I'm not sure how much I can do today. Not very much, possibly, with all of these issues. Right, and we have status, we have disconnect. I think the disconnect is the last one. We have run as well on the Wi-Fi multi. So let's see how this looks like. So that's how it looks like. And disconnect, I think there is also. Disconnect, yes. Disconnect, it's probably written Boolean. Yeah, so this one, this is the last one. Right. Yeah, good that they don't overlap. This is good thing, they don't overlap. Okay, so that's how this looks like, and here I'm just gonna take what I take in here, right? So we take in Wi-Fi multi and Wi-Fi class, right? And then I can literally copy this, move to here, right? And I need the private, yeah, I need those entries here, along with private, okay. Right, so but that would be implementation, So I need another class. I'm just gonna define it here. So that would be just Wi-Fi facade, right? So this is like universal Wi-Fi facade. That makes actually possible using completely different implementations, right? So we could have like, you know, some other microcontroller Wi-Fi and just use the Facade to as sort of adapter. That would be more like an adapter, really. So let's try to do this that way. So we have Wi-Fi Facade, and that just takes all of this. But all of those are gonna be virtual now. So this is the interface, right? This is the interface. And that's 0, 0, 0, 0, 0, and also we need a virtual distractor. Right, so that's Wi-Fi Facade, and that takes Wi-Fi Facade that just inherits from it. Right, so that's what we've got. And now what we could do, oh, there is something missing, I just realized. And that missing thing is those 2 bits. So now it should be all good. It is all good. And with the Wi-Fi Facade, I'm gonna have to split it into separate separate file. Do it later. I will do it later. And here we're just going to include that ESP8266 Wi-Fi. I will have a look at the generics example as well again, because I'm not sure if it's not better than the Facade. Let's see. Right, and I'm going to require that, but not this one, just Wi-Fi Facade. Or Facade, I'm not sure how this is. I'm just gonna call it Wi-Fi. Right, so this is Wi-Fi. And that's how this is going to look like. Yeah, that needs to be pointer though. That needs to be pointer. So that's what we will have. There's Wi-Fi equals Wi-Fi. And we can literally start calling all of this just on Wi-Fi. Right, so this is gonna be Wi-Fi, this is gonna be Wi-Fi. Cool, okay, so that uses Facade. And now having that, yeah, let me fix this one as well. Having all of that allows me to write the test finally for that. Because now I can just build, use the mocks, right? So I can use the mocks. Let me check, because I completely forgot how to do mocks. So that's how this is done, okay. Right, yeah, override keyword. Let me add it everywhere. So that should be here. That should be here. Oh, by the way, I haven't done even implementation here, so let's do it. That is false as far as I remember as a default one. Run is also something that I will figure out in a second. Right, so mode was on the Wi-Fi. Mode M. We just return it. Add AP is just return this Wi-Fi multi AP. And there is SSID and password. Status is just return this Wi-Fi status. Run is return this Wi-Fi multi run. I didn't know there is a default parameter, and this is 5000. So 5000 equals 5000. This is actually nice because we can specify the amount of milliseconds. It's just gonna try. It's also a good one. And disconnect. Yeah, that sort of like makes it a bit redundant. I mean, on the Wi-Fi Manager, isn't it? If it really works like that, you can specify the timeout for run, this is sort of like, makes this whole thing not that required, I guess. We could even potentially do it in the non-blocking way, but at the same time, running Wi-Fi multi-run might be blocking. And I suppose it is. I suppose it is. So it might be a good idea to have a smaller value. Yeah, something to experiment on, but it might be. It's something, yeah, I see there is some delays. You see there is a delay here, for example. So if we could go, if we could try to do something else, like, to block for less because of this new approach, that would be even much better. And maybe at some point, I could even change the implementation of Wi-Fi, use some low-level code, and make it really non-blocking, sorry. But yeah, anyway, let's just continue on that. So disconnect is just return this Wi-Fi and disconnect, and we're gonna pass Wi-Fi off. So that's done. So Facade is done, and let's move to our test code now. So, okay, so I'm gonna call it Wi-Fi Facade mock, right? And that's just gonna inherit from Wi-Fi Facade that we need to include, right? And we need to include the Wi-Fi Manager, right? Okay, we got it. And there is some methods that we need to, unfortunately, there's like, many of them we need to mock. So yeah, this really increases the time of development. And I might not write the test for everything, but let's have at least one case covered, because I would really like to finish this promises refactoring, future/promises refactoring. Right. So again, what we're really checking is the mode and AP. That would be something we would like to check, basically, if it happened, right? So mode, I guess it's better if I just open this Facade and just do that. So that is mode and this, and that returns Boolean. And then what we need is, we actually need all of them. So you know what? I'm just gonna do that. So mock method is where it all starts, right? Mock method. And then we have Boolean, the return type, right? So this is like that. Then we have the function name, the parameters, and the override right after this parameters thing, right? So that's gonna be here. Oh, there is no parameters yet. Here, and here. And then we're going to close like that. So that's what's happening. And now my IDE should, yeah, that's what it's done. Right, so we have all of them mocked now. All of them mocked, and I can create an instance of this mock, Wi-Fi Facade mock, in here, right? And for the Wi-Fi Manager, I can now create an instance of Wi-Fi Manager and pass this mock as the first argument. Then we need event dispatcher. For the event dispatcher, really, we don't need to have a mock. So I can use the real one, an address to dispatcher. Then there is SSID and password. And do we check for the SSID and password? Yes, we do. We would like to check if add AP has been called with those parameters. So let me define those. So we'll have const char SSID const char password. So we have SSID and password. And okay, this is sort of wrong, right? Because there should be like that. So Wi-Fi Manager. And there we go. Okay. Okay, let's see if I can run the test now. Or if it fails. Okay, that failed. That failed because the file is not found. The file is not found. And the file is not found because Arduino is not there, I guess. Which is not bad, because what I can do is to... Okay, oh yeah, I can do it. So I just need to split it out. I just need to create the facade, a new file here, right? So Wi-Fi facade, HPP, and that Wi-Fi facade will be now this bit, right? Something like that, and we're gonna have this. Oh, but there is Wi-Fi mode T that we don't have because it's a part of ESP8266 Wi-Fi type. This is not good. What is this type? Okay, that's something like that. Enum. WL status. Yeah, this is complicating it even more, because I don't have access to them. This one is WL definition. I don't think it is possible to run it on native. Let me try. So, do I have WL definitions? No, there is no such a thing. Oh, but this is interesting. Hang on. Which one is not there? Wi-Fi. If I remove it and hang on, because I moved my facade now to separate files, so I need to include it. Wi-Fi facade. Can I run it like that? No. Hang on. Oh, this is from Wi-Fi facade, from this one, because it's probably is this one. This one is okay. Wi-Fi. Yeah, we may need to test it natively. Not natively. Sorry. On. Yeah, that seems like there is no header file for ESP8266 Wi-Fi multi, which is really annoying at this point, because if I really wanted to force it, since I'm already on this way, I could force it. So instead of using Wi-Fi multi, I can literally have something like this. If not dev Arduino. But that's not good. I don't like it. I think I'm going to have to change that code and right, because yeah, let me show you. So we need the Wi-Fi mode, which is this enum. I can just copy paste it in here. But you see how problematic this is gonna be if that changes, for example. WL status, another enum. Yeah, those header files are not there on native environment. So that's the only way to add them. Right, that should be it. So if it's Arduino, it's just like that. But otherwise, else, we need to have a compatibility with both. We need a Wi-Fi and Wi-Fi multi. So that's how this is gonna work. We need to tell compiler that there is a difference. Yeah. So the lesson for me from that is that is that it's actually better to test this kind of things on ESP8266, right? Let me try to run it and see what is missing. Yeah, there's still something missing. Right, so what we've got, unknown type uint32t. Don't say this one is also defined somewhere. Facade, there is Wi-Fi facade. So, no, it's not this one. It is that facade. That, what is missing? This one. Right. This one is really, what is complaining about? uint 32. Type definition. Okay. Isn't it just unsigned int? Okay, yeah, that should be uint32t. Okay, that's how it is. Right, I see. Now it's still gonna complain about it. Let's see if I can do that. Unknown type. Unsigned int. Now it's not unknown. Pretty sure. Okay, so it is complaining here now, which is the Wi-Fi facade, and that is probably because I somewhere here I've got it included. Oh, I've got it included in the Wi-Fi Manager. So no, you cannot use facade like this. You can use just the facade like this, right? Include Wi-Fi facade. Okay. So you see, there's lots of work to make it possible, and still there is still something incorrect. Okay, Wi-Fi client .h. Oh, I see. So Wi-Fi client now. Where is it coming from? No, I don't think it is required. Too few arguments to call a single argument was not specified. Disconnect. Right, but disconnect has a default argument. So I'm not sure why this is the problem. Pull disconnect. Errors, too few arguments to call. A single argument was not specified. Right, but I've got it like, oh, I see, okay. That's how it works. Yes, finally. Okay, so finally that ran. Right, yeah, but that was lots of work to make this happen, to go for the mockist approach, and this is not the best one. I mean, both approaches are sort of not good one, right? Because if we do embedded, we need SSID and password. And think about emulating situation like, for example, if I wanted to emulate the situation when I cannot connect, this is fine. We can do it. We just use the wrong credentials. But what to do if we want to drop the connection, right? If you want to drop the connection. Or maybe there is still a way, right? I can just disconnect using the internal Wi-Fi. So yeah, it is possible to do it on native. It is possible to do it on native. And maybe that would be easier. Maybe that'd be easier. Right. Yeah, but since I've already started with this one, let's just at least finish this test. And then I show you how to do it on native maybe. Because like going with this approach. Yeah, I will go with this approach. I will finish on this approach. And another class I will do probably on native. I need to refactor this code to native anyway. Because I've just introduced so much additional work that probably is going to need to be done in the future by making all of these decisions about, creating this facade and maybe not the facade itself, which is not bad. As I said, the facade here, it's like here it acts as an adapter to the Wi-Fi. It can be considered adapter. So if we have a different Wi-Fi implementations for different boards, we could potentially just have the bunch of implementations that can, that just, meets this interface, right? Meets this interface. And then going to the Wi-Fi facade. This bit I don't really like very much because we use the Arduino, but we could do some mapping here. We could do some mapping. We could define I could define my own enums and then do the mapping. They could be one-to-one to this one. Yes and no. It's one of these hard decisions to make, to decide which approach is better. But because, again, I would like to move fast, I would also like to finish this as soon as possible. So let's finish this test. Right, so first of all, we want to expect the call. We want to expect the call on the mock and on the method mode. And on the mode, we would like to STA, right? Wi-Fi STA. Wi-Fi STA, and then we would like this to be just like that. We don't check for the value as far as I remember. Yeah, we just want to have this code. Okay, so let's see if this happens if I create one. If I create Wi-Fi Manager. Okay, yeah, so this is done. Let me check if this is really the case. What if I say ×2? Okay, ×2. Is it going to fail? Yes, it is. It failed, right? So it's just called once. Okay, so that is covered. Then we want to cover @AP. This one is more important because it takes arguments. So again, on mock, and this time is @AP, and we would like to do using namespace test utils as far as I remember. Testing. Okay, so that's testing, not test utils. And that's gonna be equal SSID and equal password. So those two methods to be called, they are called. Perfect. And now the third method that we would like to be called is this status, but we would like to make the status return WL connected, right? And that's what I'm gonna do. So let's just do expect call mock, and this is called status. Status doesn't take anything, so we can just do that. And I'll say will once return WL connected. Okay, WL connected, this. And if I run it now, it should fail. And it did fail. Okay, it did fail on that particular call. And that failed because I didn't call Wi-Fi Manager.connect. And the reason here is I didn't call it because I'm gonna have to change it. I need to change the signature of it, right? So we have connect, unconnected here, and timeout millisecond. I would like to remove unconnected completely. And that needs to return the future now. So include a future HPP, and that's return the future. The future doesn't take anything, but it returns WL status T. That's what it returns. And we can take the timeout milliseconds, right? So we do something like that. And we have this connected, and Wi-Fi status is WL connected. Then we don't do unconnected, but that would be the thing with the future. So I'm gonna create a new future would be nice to have a helper method or for creating the future as well, so I don't have to specify the generic types. Something to figure out as well. Right, so here we don't have anything. It doesn't take anything, but it needs to return something, right? And that is going to return here async result, and the async result is WL status T resolve WL connected. So that's what happens when it is fine. Otherwise, for now, I'm just gonna return pending. Right, so that's what happens. That's what happens. So here, that can be now auto future equals manager connect. And this is where we have this problem with the executing the future, right? There is no executor I could use. Hang on, let me just reload it because I think there is some Visual Studio Code issue. Doesn't like something. Yeah, okay, now it's better. We have nice colors. So future doesn't do anything on its own, but we can use the while approach for now. So what I can do is to run future, the result is pending, and while it's pending, right, we just call it. And once it is resolved, we would like to get connected, right? So there would be future, that would be asset true, future result is resolved. That's one important thing. And the second one is gonna be asset equal, and that would be future result get value, and yeah, we need to deference it, and we want to compare this with the WL connected, right? So this is what we really want to get. Okay, yeah, ideally there wouldn't be while checking for the is pending because we have some sort of executor, but also on the native environment, this is gonna be a bit tricky because I would like for the executor to use the native, the ESP8266 schedule functions that can put it can put something on the loop, a callback on the loop. That's what I would like to do, and there is no loop executed on the native, so it's probably while is the only one we can go for. Okay, this is complaining about this. That's why we have tests, so we can fix issues like that. Right, another issue is, it was in the warning, we are supposed to return it. So yeah, fail fast and fix. Nice, okay, so now what's happening is for some reason, okay, this is failing probably because the connected is not really connected. So I'm going to remove it. We can essentially rely on Wi-Fi status for that. No, that's not the issue. I think this is still like, yeah, it's still not resolving for some reason. Why it is not resolving? So if Wi-Fi status is WL connected, and that's what I did, Wi-Fi status, maybe that's the keyword here. Wi-Fi status needs to return WL connected repeatedly, or I need to use the underscore inside the brackets. No, that's not the case. Okay, something is clearly wrong, And it's for me to figure this out. So we have is resolved. If it's resolved, yeah. So that's probably, it's probably stuck on this one. So the future is pending all the time. And it is probably pending because the Wi-Fi status returns something else than connected. I could try to figure this out. Right, if I run mock here, so let me just include IO stream. If I run mock, if I just run mock, maybe at this point, dot status, will we get anything? This is probably not visible, really. Now it should be more visible. No, it's not really even running over there. Is it? No. Yeah, here probably mock, I'm not sure what mock status is gonna return. Ah, yes, so we have function call status returns 0. Right, okay, so that actually gives us some hints. So let's check what happens if I just comment this one out. And here we just do something like that. So like true or. So we make sure it always resolves. It always resolves. Right. It's probably something with the futures then. It's probably something with the futures. And let's see what it is. Yeah, so that's how this looks like. If future is pending. Yeah, that's what happens. I check if the future is pending all the time. But for some reason it is always pending. Right. It is always pending. What is the reason of that behavior? This is not even called. This is not even called. Okay, what if I just run it once? Oh, okay, I see. Yeah, that was me. That was me being stupid. So yeah, you can ignore it. Oh, come on. Such a stupid mistake. Such a stupid mistake. Of course, the result always gonna be pending because we need to poll. I think it's getting late. I'm going to have to finish in 15 minutes or so. So there's not gonna be much that I managed to accomplish today, unfortunately. You see, now this all passes, right? I had to do poll. Right, so this case is working. Should we check the other case? We can do the other case, because that other case is not very difficult. What that needs to do is to check, to run the Wi-Fi run, call Wi-Fi run, and check for the WL connected. So this is another expectation here. Yeah, that doesn't make the code much clear, the test code much clear, to be honest, in my opinion. So we have status and we have run. And that run, it takes connect timeout milliseconds, but we don't really care about it. So we do this, and then I will say we'll repeatedly. Oh, hang on, this is not the case. So that case is covered already. When Wi-Fi is already connected, right? We need a new case, but very similar code. So that will be resolves, it connect, test connect resolves with WL connected if Wi-Fi is not already connected, but manages to connect. But manages to connect, something like that. Where, do we really care about the mode and AP? Sort of yes, right? Sort of yes, so I can keep them. And here, we want the status this time to not be connected. So we would like to have something like WL disconnected, right? And this is where the new expectation, call expectation is gonna come. And that is on the run, right? So it's gonna be run, and that run will repeatedly, so like always, right? It will always return. What is gonna return? WL connected, right? So if it's WL connected, then that's what we get. That's what we get, right? So this is different. And if I run the test now, it's probably it's gonna fail. It's not gonna, I mean, it's not even gonna fail. It's just not gonna stop. Is it? Yeah, it's not gonna stop because it's always pending now. It is always pending because this is the only case that makes it not pending, right? So we need to add the missing piece of functionality, which is this bit. Which is this bit. We don't really need this connected. This is also not really required, but we would like to resolve, right? So that's what happens. And dispatch is fine. This dispatcher is fine. Nice. Okay. So this is probably covered. Let's see what we're gonna get. Something that I missed. Error. Too few arguments to call. Okay. Probably the signature on the facade, not on the, yeah, here. Yes, that was missing. So now I don't think it is required anymore. Nice. Okay, so that is fine. And the last bit is the most interesting one, because the last bit is with the timeout. Right, we would like to have a timeout here, and that timeout will make sure that if we reached it, it's not gonna continue. It's going to maybe not reject the promise, but resolve the promise with something else than WL connected. Right? We could also reject. I guess we could reject. Maybe that's what I'm gonna do. Because if you are not connected, you shouldn't continue doing whatever else. So maybe I will just reject. That's what I'm gonna do. So I'll check if it rejects with some sort of a timeout error, right? But timeout is a bit tricky with the futures. we cannot really do it. I mean, we could do it with the millis, but I don't think this is the part of the Wi-Fi manager, right? The timeout itself is not a part. I would like to make it more universal, right? To be used with different types of features. So I see the timeout as some sort of a container. I mean, not really container. This can be a feature that takes another feature. And when the time passes, the timeout is done, then it's just going to reject, okay? And not, poll the other feature anymore. So let me show you how to do this. We're going to need a separate class for it. And that's going to be the last thing I do. So I just implement the last case, which is going to be, let me at least define the test name for that. So we'll have test it resolves with, maybe test it rejects, test connect rejects with, and that's going to be a bit tricky because we don't really have the names for those errors. But yeah, let's say that just reject with a timeout error if Wi-Fi connection cannot be established, right? So that's the last case, right? At the moment it's gonna stay empty, but let's just do it. Let's finish this. And tomorrow I will speed this up a little bit, so I won't be doing much testing. I don't want to spend too many days on this refactoring. Too many days with the maybe not like myself, but recording too much material on it. I finally would like to start building some hardware. So I guess maybe we do it in the form where I do some additional work. So I finish this testing this Wi-Fi manager, and I do some additional work myself. Tomorrow I'm gonna show you what I've done, and we're gonna do some extra coding on this to finish this up. Plan to finish it up tomorrow. I cannot guarantee it, but I hope I can do it, and I will finish it tomorrow. So regardless of the state of the code, I can always add some more tests later on, because the day after tomorrow, I would like to show you this code in action. How this code can speed up development. I would really like to show you how easy it's going to be to make a request, to upload something or download something. Okay. Cool. Okay. Anyway, let's create the new class that is going to be called timeout future HPP. And immediately I'm going to create the test for it. That can be native. So that's going to be faster. Timeout future test.cpp. And let's just speed this thing up. So that's what we need. We need future HPP, and we need timeout future HPP. Right, and you know what? For the timeout future, maybe we could just have a function. Can we? Can we just have a function? No, we cannot have a function. No, we cannot have a function. It needs to be class. Right, so test timeout future. And timeout future is going to have three cases. Okay, so test it resolves when underlying with value with underlying, not sure if it's spelled correctly, underlying future value if that future resolved before timeout. So that's one. I'm gonna write the other two as well. So we'll have test rejects with timeout error timeout error if underlying future resolved before rejected. Oh, hang on, that's not gonna be the case. So with timeout error, if underlying future is still pending after timeout, and the last one is gonna be test it rejects with underlying future error if that future rejected before timeout. Okay, so that's how this test need to look like. And for that, what we're gonna need is a timeout future itself. So let me quickly create it. So yeah, we need to include a future in here. Class timeout future, and that's really gonna be something like that, I guess. For now, we can do something like this. I think that needs to actually be inherit from future though. It needs to inherit from the future. And is there any way we could do that? I think that could be done with the function though. I don't really want to inherit from the future, but I would like to have something that you can call and that just creates that future with whatever you need. So you know what? Yeah, I'm gonna try to create a function first, and I rename the file if needed. So let's define a function that returns the future with generic types, obviously, right? So we're gonna have template, and that's gonna be type name, type name, O as for an input and output type, and type name E, that as a default one is error, and that is going to return exactly the same sort of future, and that is gonna be called create timeout future. Okay, create a timeout future, and that takes the same type of future, and what it does, it returns a new future, completely new future, but as a future in here. Okay, that's probably gonna need some specializations. Right, so the future is one argument. The another argument is gonna be the timeout itself. So let's do timeout milliseconds as an unsigned long. Maybe we can do some default value, like 5 seconds maybe. That's nice value, right? And we're probably gonna need millis as well. We're gonna need millis as well. So we could have a millis here. That is, yeah, that's gonna be a bit tricky. That's gonna be a bit tricky because we don't have millis. Again, we don't have millis at this point, and I'm gonna have to do something about it. I can force millis to be here, or I could do something about it. Yeah, I will figure this out in a second. I might be able to do this. Let me show you. So we go to time now to hang on. Even dispatcher, is there any millis anywhere? I think here, okay. Yeah, so we've got millis. So maybe what I could do is to go to Wi-Fi Manager test and not to manager test, sorry, to timeout future. And before, can I specify it before I include the timeout future? Just curious. Or it's gonna complain. Okay, something wrong. Duplicated millis. Oh, I have it duplicated now because it's already in the future test. So here, so you know what? In that case, what I could do is, instead of having it here, I just specify this in the bootstrap. Can this work? Right, so here there is an issue. So undefined millis plus 50, now it's not there. Yeah, that's an issue with the millis here. Right. Where is the future test? So that is this millis here. But we probably need another millis. I don't think I can use the same one. It's not really gonna make the test independent. Yeah, if I run it like that, that's all fine, but the moment I run the millis here, it's gonna fail. So, you know what? I'm just gonna take this here for now. Yeah, also run out on the battery. I think I'm gonna have to finish. Sorry about it. So yeah, let me maybe show you how this. You know what? Maybe what I will do is I take this millis function in here. So we will have std function, and that would take void. That would return unsigned int, unsigned long. I'm gonna call it millis. I need to figure this out, how to use these native functions like millis on the this ESP266 functions, Arduino functions on the native environment without the problems. So that's gonna be something for me to figure out. Probably can be done with the headers or something. But yeah, for now, I'm just gonna do the millis in here, require them. So maybe here, right? And what I can do for that is now, because I really would like to show you what do I mean by how I see the implementation of that create timeout future, right? So we pass the future in millis, and let's say this is like the general template. This also needs a specialization, but yeah, for the input though only. So if we have input, we take that input, right? We take that input, and we call the future. We call the future.poll, and we pass that input here. So that's all fine, right? That's just, working at the same future. But the logic that is important in here is to check with the millis, right? So if we pass that value, the timeout value, we want to define timeout time, and that is gonna be the millis plus timeout milliseconds. So this is happening in the future, and the timeout time is what we pass here, what we capture, a copy of it inside this poll callback, and then in the poll callback we will have a logic as follows. So we will check against the millis, right? Against the millis, we will check if millis is greater or equal timeout time. And if it is, and at the same time future.result, right, is still pending, okay, this is the moment we would like to return the error, right? So we will have something like async result. That's gonna be with O, because this is the output, but it's gonna be reject, and something like a error timeout, right? So that's the case where this fails, okay? This is the case where it fails. So it's still pending, but the timeout has been reached, okay? And the other cases, we don't really worry about them. So I can literally here return the function poll, right? The future poll, right? Because that returns the async result. That returns the async result OE. Sorry, that should be OE though. So yeah. So even better, I can do E timeout. So use the same error type. Okay. And this is how the create timeout future is going to work. Okay. But yeah, as I said, it's very late now and, I have to finish. As you can see, this is super complex code to, adapt everything and, just, to speed up with put foundation on this rapid prototyping IoT devices. But, it's gonna work like a dream when it's finished. It's in my mind, it's gonna work like a dream. You will see. It will be as simple as doing something like, I want this device to, let's say, run something every 1 hour, right? Something like this. So we will have 1000, 60 seconds, 60 minutes, right? And every hour, what's gonna happen is, it's just example code that, I just imagine to be there, right? And then we will have something like, let's say we will have, a HTTP as client, send request, and that would be, some sort of request where you, you specify like create, and you just specify some URL and method, right? So that'd be like post. Okay, add header maybe. And you have some sort of a header. Something like that, right? Maybe X header. Right, and you send this request, and after you send it, you just do and then, and you specify something else, right? You have a function here, and you can do something like you get the response in here. Response res, right? And you will do something with the response and so on, right? So you will just have a nice chaining of all those operations, right? And also with the event dispatcher, the other approach is also going to be possible. But yeah, okay. So what I'm going to focus on off the camera before tomorrow's video is going to be on the timeout future. So I will try to figure out the problem with the midis, if there is any way to define those midis outside so I don't have to pass them as an argument. So that's one thing to do. And also I try to write those tests, and I've write the last test for the Wi-Fi Manager. So we're going to start from explaining this. I'm just going to explain how this works, what I've done. And then we jump into the HTTPS client, which is, set clock. We need to set clock first. Set clock and then HTTPS client, because set clock should be quick. And set client. And then we will have this more or less ready. And regardless of the state of the code tomorrow, when to what point I get tomorrow, regardless of what it is, day after tomorrow, we're gonna do a very interesting kind of device, something you can find around YouTube, but I couldn't really find any video where someone shows it, how to do it step by step. And I'm going to do it step by step, and I'm going to show you how to build it. So cool. Thank you very much for today. If you managed to watch the entire video, right? Respect. And Yeah, see you tomorrow. Don't forget to subscribe if you are interested in this type of content. I guess if you survived until this point of time, you must have subscribed already, because that must be super interesting to you. I'm not sure if I could survive, just watching it. Doing is different than watching, but yeah. Cool. Cheers and bye.